Well, can you believe it? Update number 30 is finally here. And with update number 30, I have answers to lots of questions I received. And I would like to start by talking about the wires. Somebody asked me, what's the wires? Well, these wires here are because I put LEDs and I'm flying this at night at times. So I have a strip of LEDs here, a strip here, and a strip back here. This being blue on both sides, this being red on this side and green on the other side, and this being all white. So if I'm seeing white, I'm looking at the back of the model. If I'm seeing blue, I'm looking at the front of the model. If I'm seeing red, I'm looking at the left side. And if I'm seeing green, I'd be looking at the right side. Also, as far as the setup, this model is being flown with a Turnigy 26, 27, 4200 kV motor with a 10-tooth pinion. It has a Pentium 40 amp speed controller. I'm flying with an AR400 receiver using a DX18 transmitter. The servo is also a Turnigy, and here's a quick little deal. I'm going to show you how to remove the tail. And actually, this tail is easy enough to remove that anytime I work on the model, I go ahead and remove the tail. First thing you do is remove the two O-rings on the upper and lower, and then the left and right side. I simply will push the ring out with my two fingers going in that direction and over the horn, and then pull it back over the horn, and now my tail is removed. To install the tail, I do exactly the opposite. So first thing I do is lay the tail up, stick it on one of the horns, pull it all the way over, and then take and stretch the O-ring over the servo horn, and then pull it back, and then push it back to center, and then make sure the rings are up against the output shaft, and then take the bottom ring and stick it on and slide it over. Take the top ring, stick it on and slide it down, and now the tail is back installed. So you can see how quick it is to take off. Remove that ring, remove this ring, shift the tail over, pull the ring off, shift the tail back over, pull the ring off, and what I do is I just clip the rings back on, and now I can set my tail aside so that I do not damage it by turning the model upside down and setting it on the table. So now I'm free to work on the model. It can lay flat, no issues with damaging the tail. This is a elevator servoless setup, so I only have rudder, no elevator, so this is fixed. You simply loosen this bolt here and loosen this one, and you're free to pivot this. There is a recommended angle. How do you get the recommended angle? You put all the assembly together, tighten the bolts up so that it is snug, but yet you can still move the servo mount. You set the model down on a flat surface with the tail mounted, obviously. You are going to take a measurement from the base of the table, or the top of the table, the flat surface, up to this point. You want to set this angle so that right now I'm flying so that the angle is set at 8 1/4 inches. So I measure simply from the table up 8 1/4, and I move the tail until I hit the 8 1/4 mark. When I have that, then I lock it down, tighten everything up snug so it doesn't move, and go out and fly it. Then from there you can make an adjustment whether you want a little more or you want a little less. 8 1/4 seems to be working fine for me, and I'm happy with it, and I see no reason to be changing that number. So 8 1/4 inches is what I use when the model is flat on the table, and then measured again from the table up, 8 1/4 inches. So now let's talk about the shoulders. The shoulders is a design that took many steps to get to this point, and I think I finally got to the point where it is a robust system where the rod, the carbon rod, is actually set in a piece of silicone tubing. And what that does is it allows the rod to float within the shoulder, but it is compressed on all four sides, or the radius, the total radius of the rod, and therefore there's never any hard point hitting the rod. So anytime you have a hard point hitting a hard point, you are going to mar it, or you're going to score it. And once you've scored it, you've actually started a fracture point. So we're not fracturing it, or we're not scoring it, and therefore, so far, knock on wood, I haven't had any more issues with the rod. So this is, there's 5 pieces that actually make up the shoulder. You have the 4 plates, and then there is a ring that goes on the rod itself, and then of course a piece of fuel tubing goes on there, and then you have the 2 bolts that hold it, and then we have the pivot bolt and the shoulder bolt, or the flex plate bolt. So with that, again, it's pretty robust. Let's go on out to the joint here, and this is sort of, I redid the wing layout, the carbon layout in the wing. And actually one of these pieces of carbon has already been replaced one time, because whenever I had issues with it turning, I was not able to turn it and actually hooked it in a fence. Believe it or not, this wing has been hung in a barbed wire fence. And there was only one hole that was put in it, and it's right there, and I just have a piece of tape over it. But the hole wasn't caused by the fence. The hole was caused by the zip tie that I had on the bottom holding some wires up. So needless to say, we don't use zip ties anymore. I put tape on it. So now, let's go on out here. Where this piece of carbon comes into the leading edge, most of the models that I've seen, that I've researched, that carbon stops about 5/8 of an inch from the leading edge. Well, I took that piece of carbon out and added a longer piece of carbon and brought it all the way up. The initial test that I did was I actually crossed it. And again, we're going to wind up with a hard point hitting a hard point, so I did away with that and did not cross it. I cut it back a little bit, but not much. Then I've taken the spring clips, which you can get at a office supply place, and this spring clip here is about maybe 5/8 of an inch long, and the depth is about 3/8 of an inch. And I've taken the clips themselves off of it so that I don't have any more weight out here than I need. Now what this clip has done for me is actually improve the lift and the glide. So when I say lift, I mean flapping lift. And it's also improved the glide. And the way that it's done that is, my initial idea was to keep this from rotating up and creating undercamber. So as it flaps, you know, this has an undercamber, and the undercamber goes all the way out. Well, if you notice, whenever I try to pull this up, see how that's springing back down, but it's not going down low. So if I spring it down, see how it's springing it back up? And this clip is, and this rod are they're working together to keep this straight. So it does have a duty here to maintain stiffness in the wing in this area. So that's why I've started using the clip. However, the downside of using this clip may be what caused my gears to start failing. Between that and, I'm going to go back to this shoulder design here, it may be that because I'm using the fuel tubing and my rod is able to float, now there's some recoil, even more recoil than what's in the carbon rod itself, and that recoil may have been what was causing the gears to fail, because my gears were failing. If we take a look at these gears here, you can see these gears were all failing in the same place. So if I take, and I probably have another set, here's another one. You can see this one here, a few extra teeth came off of it, but it's failed in the same place. If you look where the number 4 is and the number 1 is, and there's the hole. If we look here, here's the number 1, here's the number 4. So in this area here between 4 and 1, and again you look here between 4 and 1, that's where the teeth are failing. So, and that was whenever the wings were in their upmost position and actually starting back down. So I think what was happening is the gear train, it was just strong enough to work, and whenever I started experimenting with the shoulders, trying to improve the shoulder design or create a better, a more durable shoulder design, I actually took the gears beyond what they could handle, and so that's when I started having the gear issues. So now to help with the gear issues, I've actually taken, instead of using 2 gears, which would be one on the left and one on the right, I'm using 3 gears. So in a sense, what I've done is added 30% more strength because I added a 3rd gear. So, and actually if you get in technical terms, it's probably like 33%. But anyway, you get the idea. If you add another gear, then that is just adding more gear surface area, and that should strengthen the gear train. Also, I'm pretty confident that this gear here, the one that's next to the motor, the one that the wire pinion is mounted to, I'm pretty sure this gear here is going to be fine, for the simple fact that whenever I did damage a set of gears, I replaced these gears but did not replace the one coming off of the motor. And because I did not replace it, I found out as soon as I got it all back together and I did a test run up that I heard a tick, and the tick I was hearing was actually this gear with a missing tooth. And I'm thinking that I had that gear laying here with the missing tooth. Yes, I do. It's right here. So if you take a look at that gear, you can see that tooth missing. Well, I went ahead and figured, okay, let's go ahead and see how this is going to work out, because I expected to destroy this gear, and at that point I didn't care. I just wanted to find out. What I was looking for was to see if what kind of load was actually on this gear, and as it turns out, I was able to fly 3 flights with this gear and that tooth missing. So I figure if that gear is going to hold up 3 flights with a tooth missing, then there's probably not much pressure on this gear, because certainly within 3 flights I would have hit the total strength of the gear, and it would have failed, and that didn't happen. So I'm going to say that this gear here is going to be fine, even though I've reinforced these gears. So with that, that's what I've done to the gear train to strengthen it, and I think what I have done there is eliminated my gear issue. We flew it yesterday. My wife was kind enough to come out and take some video. Bless her heart, she'd never done that before, but she did a pretty good job. But the idea was we were flying in 19-mile-an-hour winds. We have a weather station monitor at our field, and of course inside one of our rooms is that station readout, and the station is actually set on top of one of the shelters out there, so whatever that is saying is what the wind speeds are at the time, and of course it was anywhere from 17 to 19-mile-an-hour winds, and it was pretty steady. Well, I flew the model, and the gears held up just fine, and I had no issues, seen no issues, and even with the elevator servoless setup, the model handled the wind really well. I did not edit any of the video to remove any of the footage, because I did not want, you know, when I look at a video and I see it all chopped up, I'm thinking, well, maybe I'm just seeing the good parts. So I try not to do that in my videos unless something happens, either the battery goes dead or the disc fills up, that will more than likely be the only, or unless the flight is just really boring and it's obvious that the model flies, then there's really no need to let you sit through footage that is just repetitive. So I do the best I can, but I always keep in mind that, you know, if you edit videos, you're probably editing the bad parts out, or maybe the parts you don't want people to see. At any rate, that is pretty much the wing, the gear train, the wire issue as far as what were the wires about, and also the shoulders and this clip. One other thing I guess would be what I've done at the back of the wing. My backbone is a one-piece backbone, and so I did a couple of different things here. On this side, excuse me, on this side I was able to stitch by hand around the carbon here, and also down the backbone leading edge there, just to keep this tape from coming apart or from lifting. And so on this side I stitched it here and here, and on this side I only stitched it a little bit here. And again, it's to keep the carbon from actually taking and lifting the tape off. Well, as it turns out, either way will work, because this side it did keep it down, and on this side it kept this tight, but it didn't lift in here like I thought it might. So I think if anything, we can just run a couple of stitches here just to ensure that this stays tight and not lift over time. Now obviously I've flown this model in wind conditions people would never fly their Ornithopter in, and I've done that not to show how durable or how well controlled or any of that. I've done that so that I can see the durability and find any weak points. I figure if you're gonna find a weak point, the best way to find it is whenever you put it under loads that it normally is not put under. So that was the reason for flying in the winds. Plus right now is our windy season, if you will, and we don't get a lot of calm days. So the weather conditions, I mean, I can fly it at night. I can do that, but I can't get video at night. So I'm confident that the model flies, and I'm confident that it handles really well. That's why also you notice in videos now I've started slowing down doing a replay in slow motion of the landing, so you can get a real good idea of the landing technique that I'm using, because I do not have an elevator to flare, which might be a good thing, because if you don't have an elevator to flare, then you don't also have an elevator to stall the model. So, and that may be another reason why the recovery from the anhedral situation has been really, really quick, because I don't have an elevator to worry about control input to. It's fixed. So all you have to do is flap once, and the model will upright itself and then go into pigeon mode, and then from there you can advance the throttle to hit glide. And that's also the other thing that I've started doing, is basically whenever you flap, I flap into pigeon and then just advance the throttle for a brief second so that I see the wings start to move. And the idea is for them to move down far enough for it to go and catch the glide lock, or go beyond the glide lock, and then whenever the weight brings it back, it brings it into glide lock. So that's the last step that I want to improve on, is the glide lock. And I think what I'm going to wind up doing is modifying my glide lock, because right now I only have one, but I'm going to see if I can work it out so that I can use only one, because the gear train took up the space that I was using for the one on the other side. So if I can work it out so that I can use one glide lock, have two glide lock positions. In other words, what you would do is you go into glide lock by hitting pigeon mode, and then advance the throttle. And as you advance the throttle, the wings come down, and as they come down, they would stop and then back up. Well, the idea is if I have a dual notch on the glide lock, then maybe whenever you first hit pigeon mode and you throttle up, the wings would come down, say to about there, and then when they backed up, they would hit the first notch on the glide lock, because what that would do is let you kind of step it down into the angle you wanted. So let's just say it was really windy and you didn't want to come near level for the ultimate glide. You just wanted to slow your descent rate, so you would hit the first glide lock. Once you hit the first glide lock, then you again advance the throttle a little more so that the wings came down, and once they got to level, then they would hit that second point, and then when they backed up, they would be in a new glide lock position. However, if you went beyond the bottom dead center, then what you wind up doing is going back and up into pigeon mode again. So then you get to attempt it again. So you advance the throttle, you come down, you hit the first glide lock, and if that's not the one you want the next one, then again you advance the throttle a little more, it hits the second glide lock when it comes back up. And so it's basically you advance the throttle a little bit to hit glide lock. You're not worrying about a timing issue where you stop at the right point. Doesn't matter where you stop. Matter of fact, it's best if you stop in glide lock or in pigeon mode, and then advance the throttle down till you hit the glide lock that you want, which would be one of two positions. So I think I've run on now for a little long. I apologize for that, but I thought the information that I was going to provide to you here was going to be very helpful and useful. Maybe if you're designing your own ornithopter, maybe you could take some of the stuff that I've shared and be able to use it and benefit from it. So with that, thanks for your time and enjoy the hobby.